Andrew Christos Erotokritou.
Perfect.
Hey,
that's it.
I was going to talk about Apache Ignite and other things. So, with that, Christos.
Great, thanks guys for having me. Hopefully you stick around for another half hour so we can cover this off. I think I'm going to do a small introduction, I think, to the latest kind of project that's graduated from Apache Software Foundation. It's called Apache Ignite, and it's an in-memory data fabric. So a little bit about myself. I'm a GridGain employee. Previously worked in the same space with Gigaspaces around the data grid kind of domain, and only recently joined actually GridGain in January. So a little bit about the agenda. I'm going to talk a little bit about the project, talk a little bit about the fabric, the different feature sets, delve into a little bit more detail for each of the components, look at a few use cases, and then hopefully get some time to do a demo and some Q&A at the end. Okay, so the Apache project. Back in 2007, we had the two founders of GridGain, which is Nikita Ivanov and Dmitry Setrakayan, if I got that right. They started with GridGain, given their previous kind of experience in the HPC sector. They developed what they called GridGain Compute Grid. And then in 2014, they contributed this project to the Apache Software Foundation as Apache Ignite. Now, Apache Ignite was the second fastest graduating project from the Apache Software Foundation after Spark. It's a pretty mature code base today, so with about 700,000 lines of code and a number of commits, 16,000 commits, growing number of contributors. We've got about 60 at the moment and growing rapidly every month. And yeah, a huge development momentum. I mean, you can go check out the details on OpenHub. I took all this stuff from there, and you can compare it with other kind of open source projects in the same domain. Okay, so what is Apache Ignite, and what do we mean by an in-memory data fabric, and why do we call it that? So basically, it's a set of components or in-memory components that help you solve scalability and high-performance issues. So it's not just a data grid, it's not a compute grid, it's not a Hadoop accelerator, it's a number of different things that when we put together, each of them serve for a separate use case or a number of different use cases, but all kind of follow in the same kind of concept, being in memory and helping you solve scalability and high performance issues. So I think it kind of touches on where Akmal finished off, where there's some technologies out there that kind of try to put everything together and provide a number of different APIs and features by which we can access. I think Ignite is one of those technologies, and actually working in memory makes that even faster. Okay, so let's look at a bit more detail each of the different components. So for a data grid, for example, something running in memory, your standard kind of web session clustering, where you can have a session cookie shared across a number of application servers, standard caching, key value stores, what have you, or even in-memory SQL. And I'll go into each of these components over the next few slides, kind of briefly, and talk about the features that each of them provide. Compute grid, kind of standard HPC, classic, high-performance computing, map-reduced jobs, machine learning, executing jobs in a distributed kind of fashion within the grid. Service grid, running resilient, highly available API services as cluster singletons or as a node singleton and so forth. Streaming and Hadoop, that's a pretty big space right now, pretty buzzy. You hear a lot of things around real-time analytics, big data, and all that stuff. Definitely something that we're going to cover and something that Ignite does very well. And also we're going to talk a little bit about how do we do that, the clustering, how do we provide resilience, how do we manage cross data center replication and so forth. And a few other kind of basic components, file system. So if you look at the Hadoop HDFS, this is an IGFS, so an in-memory file system. Talk a little bit about that. Messaging framework that we can do in-memory messaging between the different nodes. Events triggering, again, complex event processing or event-driven architecture within memory that we can execute, or even standard plain old Java data structures. So each of these you can see, they can cater for a number of different use cases themselves. But all put together, I think this is why we call it an in-memory data fabric, because all these put together create this in-memory data fabric that help you solve all these different kind of challenges. So customer use case, I mean, we've got a number of different customers right now, all in different systems, from financial trading systems to massive multiplayer online games, to OEM customers building their own platforms, empowering it with an in-memory grid. Big data and real-time analytics, streaming services, so forth. I mean, there's a number of different stuff you can do. And again, like I said, this kind of technology and working in memory, it could be expensive when you're working with RAM. So it's only about kind of solving really high performance challenges and scalability challenges. If you've got a limited data set and your latency or your performance is not really important, then you're probably better off going with something like a disk or even with a SQL on top of an SSD drive. Okay, data grid. So first of all, Ignite is a fully distributed JCache compliant data grid. So we offer basic cache operations, so the simple kind of key value operations, read, write, delete, update. We also support co-located processing, entry processor, by which we can execute a piece of code or a manipulation or an update to a specific entry as close to the code as possible. So I don't need to read the data and then do the change and then write it again. I can actually ship the operation that it needs to be executed, like updating, and this will be executed there. Pluggable persistence, so the ability to plug an external RDBMS or a NoSQL database and so forth. So it comes with all the basic JCache kind of standard approaches, and we also add what we call fault tolerance and scalability. On top of that, fully ACID transactions, fully ANSI 99 compliant SQL that can run in memory, and also in-memory indexes and automatic RDBMS and NoSQL integration. So I can work with any kind of data store in the background. Make sense so far? Yep. So let's look at a little bit how do we handle fault tolerance and scalability. So being a distributed data store, and we always take the approach with Ignite as we want memory to be the primary store and moving the disk or the database in the background. Now, to be able to say something like this, we really need to provide features and capabilities to be able to resolve and to be able to guarantee data consistency and resilience and fault tolerance in the grid itself. So we employ different methods from modes, from a fully replicated cache, where all the data will reside on all the nodes and the processing can be distributed, or we can have a partitioned cache with any number of backups from 0 to none. When backups, we say, you can see this concept when you're talking about Mongo, they call it replicas, the same with Elasticsearch. It's all about having a primary kind of node and a backup node or more than one backup nodes. So when one of these fails, the backup kicks in, we restart another primary node and we're back to that. A really cool thing that I haven't seen a lot of other grids doing out there actually is the ability of dynamic rebalancing. So in any case, if I add a new node to the cluster, there's actually dynamic rebalancing that happens in the background that we could either choose to be fully async, so we don't care about the replication when it actually happens, or we can choose only primary sync. So there's a number of different modes you can employ on how you rejiggle your data around. So generally what that happens is a couple of the primaries will relinquish some of the keys, the new node will pick up some of the keys, the backups would also be created, and the data will be redistributed across the nodes. Now, of course, if we always want to maintain consistency, there's different modes that we can operate. For example, we can block all operations to the grid until it's fully rebalanced, or we can choose only the backups to be rebalancing, and we don't care if we're going to do some operations there. The same goes with the backup. So we can wait for the backup to come up and fully replicate and block any operations to the grid, or we can choose a kind of approach that this happens fully async in the background. Yep.
Is this basically the main similar as Hazelcast? Or
Yes, absolutely. Yeah. Not similar. I think we're better. So.
Is that how we ourselves are looking at GBoss InfiniSpan?
Yes.
Is that something?
Pretty much. Yeah. Yeah.
Can you repeat the question for the video?
Yeah. So I mean, the question was, is it similar to Hazelcast and InfiniSpan? Yes. I think Hazelcast and InfiniSpan, I think they're more sitting on the data grid side. I think we offer a much rich feature set when it comes also to compute and all the different plugins that we offer around the space. And I think you'll see a few features that I'm going to walk through now. I think that probably will differentiate us from Hazelcast or InfiniSpan. I don't know very well InfiniSpan, but probably with Hazelcast we'll see that there. So yeah, I mean, fully replicated cache, like I said, it's really down to you on what mode you want to use and how you want to do that. And it's down to the performance that's actually required. External persistence. So we do support any number of kind of read or write throughs to the database, or even write behind. So we can choose and mix a number of our entries sitting in memory and a number sitting in the database in the background. If we have a cache miss, what we call, we can always go back to the database, fetch, warm up the grid, and have this data ready there. The same, we can also do dynamic loading of the grid, or when we restart the grid, we can bring up data from the database. We can also do write behind or sync write, so we can always push into the database as part of a transaction if we want, or we can even choose to just write it into the grid, get the response and say, okay, that's been written, and then let Ignite handle the synchronization with the RDDs or the database in the background. And again, I think another really cool feature, there's a DB schema mapping wizard that comes actually out of the box. So you've got a standard RDBMS, you can run this, connect to the database via JDBC, it'll generate all the XML, all the POJOs that are necessary. Yeah.
One of the reasons I used Infinite in the past was that you could very easily configure it as a second level cache for Hibernate.
Yes.
It was a killer feature.
Yeah.
You would understand, obviously. Do you have anything like that?
Yeah, absolutely. We do support out of the box with Hibernate. One of the most recent ones now we're actually building integration with. That's the beauty of being an Apache project. They've got a lot of contributors. It's actually MyBatis. I think that's another kind of similar product that's sitting in the space. Hibernate, definitely. That's one of the first things that we supported with second level cache. So yeah, you can check that out. So not only kind of horizontal scalability, so not about just creating a cluster and bringing up new nodes and spreading the load, but we actually support technically unlimited vertical scalability, meaning we can actually store our objects outside the heap of the JVM, which enables us to avoid kind of lengthy garbage collection cycles if we're keeping a lot of data. And also the same with the indexes. If we've got a lot of indexes and we don't want to keep it on heap, we can also configure that to be pushed out. Now, the same way, we've got eviction policies. Also for the kind of the previous slide, we can also decide how we evict data, how we expire, and we push it out into the RDBMS. The same thing with off-heap memory. We can have a simple configuration that allows us to push data from on-heap into off-heap after a certain threshold. Or we can decide on a specific data type, for example, to reside on-heap or off-heap. It's really a simple configuration, and you're welcome to check it out. Yep?
When you say off-heap, you're not talking about the JVM heap?
Yes, outside the JVM.
Oh, so you're using node?
Yeah, so it's serializing outside, and it's the same thing, I think, that also allows us, and you see one of the enterprise features, actually, we've got on-heap, off-heap, we call tiered memory, which is on-heap, off-heap, and also local persistence store, or any other persistence after that. So once we're outside the heap, we've deserialized and we're ready to push it anywhere we want. Yeah, I think it's a pretty cool feature, this one. I think, and back to your point, what does Hazelcast offer? This comes actually with the open source version, with the off-heap. I think Hazelcast offered this in their enterprise version. So. Okay, so cache APIs, how can we query the grid? There's a number of different ways, from simple scan queries where we can test on a specific criteria, on a specific value, based on a, let's say, bring me all the employees that have a specific, I mean, it's too small there of code. I think it's just for picture purposes. I'm going to share the slides later with some links so you can check out if you want at your own time. But basically, there's a number of different APIs we can actually use. We can even do text search, which is based on Lucene indexing. We can do SQL queries, which you'll see in the next slide, which are pretty cool. Fully Memcache support for PHP, Java, Python, or Ruby clients. Full-blown REST API that you can hit. You can access server from there, or even a JDBC connector if you want to use. So I think, recently joining actually Gridgen, and I'm starting to understand that this is a killer feature. I don't think there's any grid out there, and we see when we're talking about Cassandra, they have the CQL that we're talking about. I think this is the only kind of technology in memory grid out there, I think, that provides full-blown SQL capabilities. I mean, you can run cross-cache joins, for example. So if we think of a key value store, if you know the key, then it's pretty simple. It's obvious you're going to use something simple like Redis, go fetch it, it makes sense. But I think the more data you have, the more intelligent questions you want to ask. For example, bring me back all the employees that are working for a specific organization. If I have to do this with a key value store, then there's a lot of logic that I need to run on the client side. Do a full scan, bring all the objects, do a full scan of the other cache, kind of merge it together and work on the results. We support this out of the box. So I mean, you can run any pretty much query that you want against the grid, and then that'll work. And actually, we don't go ahead to kind of invent our own SQL query language. We use a local H2 engine that's running local on each node. If this is a local query for running in a full replicated cache, then any actual SQL query will execute in any node because all the data is there. But if we're running in a partition cache, actually what we do in the background is a map reduce job. We split it out in a task, we ship it out to all the different nodes, get the result set, reduce it, and bring it back as a nice data set. Is this something that has been interesting, I think, in terms of SQL? Go for it.
So I think one of the things we've been exploring is, I think, cross-cache choices, like you say, it's a pretty hard problem to solve. So the way you're doing this is basically there's a SQL engine, like H2, which is basically running SQL.
Yeah, exactly. I mean, what it does is, like I said, you'll split it up into, the question is how do we actually execute the query in the background? Yes, it's the local H2 engine or running at per node. We ship out the query that we want to execute, the SQL query, to each of these nodes. The result set is then gathered and then shipped back to us, and we have that. If we need to do joins, again, and we benefit of the collocation of the data. So for example, on a certain node, when we have a person and the organization, and we've managed to collocate that using an affinity key, when we're going to execute that query, it's going to be very easy to do the join on the server side on the node and then ship it all back.
But if it's actually on different nodes, you can do network.
Yeah, I mean, you're going to have to take that overhead if it's on different nodes, because there's going to be the network latency, but you'll have to take that hit if you really want to go out for horizontal scalability. So there's no other way you can actually do that. Yeah.
The question is that if I wanted to use a graph database rather than a SQL database or relational database, is that possible? And also, if I wanted to use Scala rather than Java, is that also available?
Yes, we do support Scala when it comes to that. But actually, you said a very important thing, and you reminded me to mention something. And actually, right now, so when it comes to SQL queries, we can all do that in memory. Now, remember I told you before about an external persistency store. So if that's an RDBMS and I want to use that as a background store, now we do not support executing SQL queries in the external persistency store. So we can only execute it in memory. But actually what we're working on in the next couple of months, and I think in the next quarter we're going to have, is a common interface. So executing the same query with a read and write through. Remember, we have the read and write through when it comes to simple key value, but what actually we're working on is to actually do that with a SQL query. So you can then mix and match any amount of data sitting on your disk and also sitting in memory. And then you can always speed up things and say, okay, now I'm going to push up the notch, store more stuff in memory, store less in disk. You know, it's a high peak time, or then you can choose to store more in the disk. So I think that's where we want to get. So from the user's perspective, we want to completely abstract that, have a common interface by which we can query that and configure what the speed you want it to be. Transactions. So we're talking a little bit about transactions previously. I think we support fully ACID cross-cache transactions. So starting from a block of code, you can access from any object from any cache. We support optimistic or pessimistic locking. So with optimistic, we actually, each of the entries that are sitting in the grid is actually a comparable. So once we bring it back, and this is done automatically on the commit stage, we'll check and we'll see if if that version has changed in the grid, if there's a new version, and then we'll throw an exception, which you need to handle on the client side. Now, actually, with one of our latest customers that we've done a good exercise, and we've implemented what we call kind of a deadlock resolution or protection in the background. So if you run optimistic mode with a serializable isolation level, there's multiple isolation levels that you can run, we actually have a view in the background in the sequence by which these transactions are actually occurring, and we try to see if there's a specific way that we can execute them to actually not throw exceptions and have any problems with these. I think if you run the latest, if you check out the latest actually benchmarks that we did, actually a good comparison is with Hazelcast. We actually have twofold the amount of successful transactions completed against the same test with something like Hazelcast. So I think, and you can understand most of our customers so far have been in the financial services industry. So having a strong transaction API has been very important for us, and it's something that we've been grilled on all the time. So yeah, huge case study. This is the bank that we're actually talking about right now. these guys, we just managed to close the deal in the end of last year. They're doing a huge investment in GridGain, which is the enterprise version of Ignite. And actually what they're doing, they're trying to migrate all their architecture into a more agile in-memory platform so they can have much faster and agile development of their services and new services. They've understood that a lot of the they've understood that there's a lot of competition out there which are not banks. For example, Apple Pay or PayPal. There's a lot of businesses out there that are starting to steal the food of these banks. So initial first step is like, how do we change what we have to start having a better platform by which we can expose and give our users new services and the ability to create themselves new services. So we want best performance. I think this was almost more than a year of kind of testing, rigorous testing that we had to go with Burbank. And like I said, most important things that actually gave it to us was the ANSI 99 SQL support and our transactional consistency. So those were the two key things that they found very, very important with us. And again, another very important bit there is the strict SLA. So we actually implemented a local disk store, which is the tiered memory. So on heap, off heap, and a local store. So this will store it at a local node. So then when you restart it, we can recover from the actual node itself and start the grid. And actually, you know, one of the main reasons here is actually minimizing their dependency on Oracle. So getting rid of that technology like coherence is number one on their list. Another couple of features that I think we're talking about, continuous queries. Again, it's really down to you to understand what use case perhaps you might want to use this. This is about starting with an initial kind of query or a subset of the data, which we can execute, what we call the start query. And then we can create a filter on top of this query that matches a specific change of our data set, for example, and then create a local listener on the node that will execute a specific operation when any of these data changes and matches our filter. So, I mean, already I think there's a number of different ways which you can use the grid, which you can interface with the grid, the data grid itself. And we haven't even gone to the kind of compute side of things. Another important one, distributed Java structure. So the standard distributed map, which is our cache, our data grid. Distributed set queues, that's another very cool feature. We can have a blocking DQ, a distributed one across the cluster itself, countdown latch, atomics from long sequences, even distributed semaphore implementation that we have, and a standard distributed executor service, which we'll talk a little bit now when we're looking at the compute grid. So that's just using the standard executor service in Java, but having the ability to distribute your executions across the nodes. Yeah.
You don't do pub sub with it.
Sorry?
Can we do pub sub with it?
Yes, and I'll go to that actually. I think that should be the next messaging and events. So this is where, to answer your question, yes, we can do topic-based messaging and subscribe to a certain topic and be able to consume that. So we'll get to that in a sec. So yeah, data structures, pretty standard. All your atomics, you got to understand, you're accessing from any kind of client or any node. This will be the same kind of atomic variable. So one can increment it, one can read it, anyone can make the change, and it's still an atomic interface. So another useful kind of use case, or where we see a lot of the uses, simple uses of the data grid, is simple kind of web session clustering. So we've got an implementation. It's actually a section on our webpage that you can check out. It's all about adding a layer by which we can share the session across our application servers. So this way, no more kind of sticky sessions where we need to always redirect the user to a specific kind of application server that doesn't matter anymore. And not only that, actually what this provides is if any of these application servers actually goes down, it doesn't really matter because anyone can pick up that session and serve it to your customer. So, and again, scalability, you know, technically unlimited scalability for scaling out and scaling up. So pretty cool stuff. So yeah, a little bit about the compute grid. Standard MapReduce API that we provide out of the box. We call it kind of a compute task, which we can specify a closure that we want to execute on the grid, or a runnable or a callable that we can ship over. We've got also cron task-like scheduling for your traditional kind of HPC needs where you want to schedule a set of jobs that need to run on the grid. That's no problem. We also support state checkpoints. So if at any point, any of these jobs, you can use an API to set a specific state. So if anything happens, the grid crashes, everything comes crashing down, we can always resume from that checkpoint. And you can set multiple checkpoints, and you can always come back to that. So think about a state for a specific compute or job that's running. Of course, load balancing, we can decide whether we want to broadcast our jobs equally. We can select, we can have cluster groups, first of all. So we can have sections of nodes which are compute and data, sections which are only compute, and sections which are only data, or multiple combinations of these. And then we can choose where to execute our jobs, ship them to a specific cluster group, or to only client nodes, for example, or to even use a kind of only one node executes a job at any given time. So only kind of a serial execution. So there's a number of different ways and methods that you can actually use the grid. We also support zero deployment. So we've got a distributed class loader. So once we're gonna ship a task or we have a closure that we ship over to the server, then it's very, there's no need to load all these classes in any of the other nodes. There's a distributed class loader in the background that kind of loads it and then pushes it out to all the nodes, and there you go. So yeah, support Java 8 Lambda expressions. We can always execute distributed closures in the grid, the distributed executor service. We also support sync or async. I mean, we don't expose your traditional approach async methods. Actually, what we do is we expose an async API for most of our operations, from the compute grid to even to the data grid, that we can execute synchronously or asynchronously, waiting for a future or waiting for an instant result. And we also support remote task deployment, meaning I can upload from another node some set of tasks or closures or executions that I want to run, and then call them from another client node by their name, not having to ship the task there. So we can just remotely call the execution, so where we have one system loading the tasks and another system executing the tasks in the grid. Use case, compute grid. So I've got two use cases here. One is in the US, Silver Spring Network. So these guys, they do kind of smart metering. So I think what British guys are trying to do right now with their smart meters spreading out. So they've already started, they had an implementation. It was pretty slow. It wasn't performing to their standards or requirements. And it wasn't only about just collecting the data. It was actually all about asking interesting questions around the data that they were collecting, because that's the beauty, I think, of Internet of Things. You can bring back a lot of data, a lot of sensors, a lot of information, but actually, how do I make sense? I gotta be able to ask interesting questions there. So what we brought to the table is strong compute, because we have the ability to collocate our compute with our data. So remember, when we're talking about partitioning our data, we can use an affinity key to decide where that piece of information sits. Now, the same way we can use with a compute task, we can use an affinity key and always make sure that that task is executing where the data resides. And again, demonstrated best, I think that ANSI 92 SQL support is one of our key stuff that is winning us a lot of the deals right now. And then transactional consistency, that's always there. Another very good, these guys are up in Oxford, Ethiopics. They're pretty new startup. I think they've only been around for a couple of years, but they're doing some very interesting research. They're running, they're using GridGain as a distributed compute grid to do a lot of analysis in terms of a lot of compounds and medicines and understanding the different symptoms that are occurring and coming up with a list, let's say, of potential candidates, which then are run in the lab and find out how they can be used as new medicines. So again, strong compute comes down to our collocated compute and data, because I've seen a lot of cases when it comes to compute, and that's another stuff that's coming up with data, your traditional kind of grid computing, where you would always kind of ship the data with the jobs that you would schedule. Now, this is increasingly becoming a problem because there's a limited amount of data that can ship with the job. So having the ability to have the compute layer and also collocate the data and do the execution at the same level is very important, I think, and it's just doing it very well for us at the moment. Yep.
When you say compute, Is this similar to the way VaultDB lets you write Java store procedures and process? I mean, I just basically.
Yeah. So is it similar to VaultDB? You mean in terms of the interface, or?
Yeah, I mean, in terms of architecture, it's a bit of apples and oranges situation, but most of these in-memory systems fail to give you access to code that you can run completely on the server side, and then you have to do exactly, like key value stores, what you described, just and it kills it because you're pushing all those requests. So this is a piece of code that runs completely on the storage node.
Exactly. Okay. So and this is where I mentioned before. So the question is does it actually run on a compute node or a data node? Actually, you can have any combination of that. So in an Ignite topology, you can have client nodes and you can have server nodes. They can both actually be part of compute. So even your client nodes, you can decide they can only be used for computations. And now your data nodes, your server nodes, can also execute pieces of code, but they also have the underlying data. So it's really down to you how you're going to mix and match these operations. So again, it's not a simple problem. I think you talk. It's really down to the use case and understanding. First of all, we got to understand which data we're going to collocate together. So it's not only collocating compute with data; it's also collocating data with data. Getting, for example, when you have people, I want also the organization, for example, for that to be sitting on the same node that are related to those people. So it's exactly the same thing. I think it's a complex problem, but what we provide is the ability to execute pieces of code on the data. Yeah.
In that case, I have to ask, you mentioned it. Do you have a mechanism to ensure data locality by just custom hashing logic, for example, for distributing values across nodes?
Yes. So how do we distribute the data? Actually, we use an affinity key. It's a hashing operation. So once we've got this key, let's say based on the ID, then we will decide where this data will reside. And again, if there's any rebalancing, again, this actually will happen automatically in the background if any keys will be moved against that. Any compute task, let's say, I've got a topology change. My primary node is now, my keys is with another node. Again, the compute task, because you're going to be using the correct affinity key, will again execute in the same location. And I'll talk to you a little bit about the services, how we can even co-locate services as part of this. So pretty cool stuff. Which is this, the in-memory service grid, actually. So it's, we all kind of worked with the traditional kind of services where we can expose our own custom APIs by interfacing the grid. So this is about, we can either have a cluster singleton, so guaranteeing a single instance of a service that's cluster-wide, fault tolerant. In case that fails, we guarantee that this will be restarted on some other node. So guaranteed availability. We can even have a node singleton, so I can have an instance of a service running in all my nodes. Or I can even have a key singleton, which I can use an affinity key, and I can always guarantee for all these keys that are using this key, if there's a topology change, and now I've got 6 nodes and some of my keys are now in node 6, because this will be deployed using an affinity key of its own, it will always reside where all the other keys are there. So very interesting stuff, definitely. I think this is one of our strongest points, again, when it comes to, I think, services. Yep.
How does this sort of map to the cloud? Are nodes individual machines, or how does that work?
Okay, good question. So what are nodes? Are they individual machines? Are they physical servers? It's really down to you. It's a Java process. It's running in a JVM. We can run actually multiple instances within a single JVM. I wouldn't recommend that, but that's probably for testing purposes if you want to do that in your own IDE. But ideally, you can have any number of nodes, I think, on a physical server. It's really down to you. They can run on VMs. It's really down to you how you're going to separate them out. So, yep.
Do you provide some sort of management tools that allows you to see and monitor what is where in this?
Yep, absolutely. So you can pay for some good management tools. That's our Enterprise Edition. But actually, no, there's, for a nice user interface, yes, that's part of the Enterprise Edition. We call the Visor. I've got some slides in the end. I'll quickly go over that and why they're in the Enterprise version. But there's also a command line tool, a command line Visor that we use. I'm not sure how great that is or how much insight it provides, but I I think there's a number of different, the best one is the Visor, and that's the one that's coming with the enterprise. But it's an open source project, it's an Apache project, you're welcome to go contribute, create new awesome UIs, and then we'll take them in. Yeah, go.
So, somewhat related, but in relation to your SQL interface, let's say I'm running a SQL query and it's not performing well because you're doing a map reduce across however many nodes. How do I track down? Do you have some way of tracking down, where the bottleneck might be, where the problem might lie? Is there any, logging, server side, whatever?
Yeah. So first of all, we've got extensive kind of auditing and logging in terms of what's happening in the grid. Every event is actually captured, and we can audit every operation that's occurring, even replicate operations from node to node. How can we debug it? I think it's pretty hard. I think I don't know if a standard tool that we use at the moment. It's probably coming in, understanding what we're looking at, and if there's a standard kind of pattern of what's happening here, we don't expect latency to occur, then we'll probably have to investigate and understand. But I don't know of a specific tool, at least to my knowledge right now, that we use. I mean, bear in mind, I've only joined myself in January, only 4 weeks ago. So, but we can take that offline. I'll check and see if there's anything we can answer to that.
Sir, one question.
Yep.
If we have an architecture where we have just one database, but there are multiple applications, and not all applications want to use this in-grid, the software.
Mm-hmm.
How does this grid database be kept up to date?
Okay, so the question is if you've got multiple users on a database, and you want to use that database as the backend persistency for something like so we have a grid, and then we've got a database that is actually accessed by a number of different systems. Ooh.
Writing into that database, then how does this data grid stay up to date?
So it's an interesting question. How does it stay up to date? So can we propagate changes from a database into... With Oracle, I know we do support Oracle Golden Gate. So if you need to propagate any changes for any Oracle database, then we're welcome to do that. So we've got integration with that. So any changes from that will be pushed into the grid. For any other implementation, I'm not so sure. We'll need to check, I think. But I know for Oracle, that's what we provide.
Is that the enterprise or the open source version?
It's a good question. I'm not sure. I'll check. Let me check and I'll find it out. I think it's. I think it might be enterprise. I'm not sure. Might be wrong. I'll need to check. So okay, messaging. I've got about 10 minutes, so I think we can run through this. Topic-based messaging. So like we said, we've got the capability to publish on a specific topic, consume that either in ordered fashion or unordered fashion. We can have local or remote message listeners, so listeners that are deployed across the cluster, and any node can execute any operation on that, or even a local listener only for a specific node. And like I said, for the events, you can see here, we've got basically interceptors for any sort of event, from put, read, remove to any operation. We can intercept and capture and take an action on that. Of course, you gotta be careful here. You don't wanna be intercepting everything because you could create a bottleneck in the grid. In-memory streaming. So really important kind of stuff that's coming up now, and with big data, I wanna see all my data, but I want only a sliding window. I don't care about the historical data, at least not right now. I can push it into another kind of database. But actually what we can do here is we can start with a kind of a FIFO eviction policy. So we can say, okay, I want my stuff to live in memory for 1 hour, let's say, for example. So everything after that gets evicted. And then we have the ability to actually, we configure a data streamer. So we're streaming data in parallel into the different partitions. Remember, if we're running in a cluster, you can always be streaming directly and in parallel to all the different partitions. And then at the same time, we can actually execute a SQL query on top of that. And I've got a small demo at the end that hopefully maybe I'll get a quick time to show how that works, but hopefully we'll get there. Hadoop Accelerator. So I'm not gonna say, you should go and build that stuff, but if you've been using Hadoop and if you've used MapReduce, this is a very chatty operation. It's not great, hence, now Spark is coming out and all the new stuff on top of there. But if you've got existing Hadoop implementation, actually with zero code change, with any Hadoop distro, we don't use any name node and no network noise. We use our own implementation in the background, which is using our in-memory kind of platform to be able to speed that up on top of, and we can always sit on top of HDFS if that's necessary, which is actually the next slide, an in-memory file system. So we can also speed up an HDFS where we can have an in-memory. So think about when we have a traditional database and we can add a caching layer. So this is almost the same as having HDFS and then having an in-memory file system caching on top of that. Now you can choose to have a combination of both, or you can choose to have only the in-memory stuff. And I think the next slide is an interesting one. Has anyone worked with Spark? Yeah. Great, number of people, cool. So basically, I mean, if you kind of work, this is great when it comes to kind of machine learning, fantastic technology, really cool. If you're already using it and you know about Spark RDDs, this is about, they're actually immutable and they're not shareable across jobs. So with an Ignite RDD implementation, what we're able to do is actually share these RDDs across jobs or across nodes or even globally across the cluster and have a common and have these shared data backs where we can access. And again, if you know Spark, there's SQL as part of this, and actually we speed that up. So they don't provide any in-memory indexes, but actually when you're using our integration with Spark, we provide the SQL indexes being in memory, hence speeding that up even more. And deployment, this is a quick one. I think this is probably the last slide. We support, fully Dockerized kind of Ignite. You can specify the version, we'll create the Docker container, no problem. Amazon AWS, we support discovery. They don't support multicast, so we've got S3 discovery. So we'll write it in an S3, and then we'll be able to read and understand which nodes are powered. Google Cloud, Apache JClouds, Mesos and Yarn. So if you're using Hadoop, you probably know that. And Mesos is another cool stuff. We're fully compliant with that. And Apache Carafe, the E needs to go there. That's autocorrect. It's not a carafe of wine. Okay, so I've got, I think, yeah, and I've lost. Where's my demo? So a little bit of the last couple of slides. So what's in the enterprise version of Grid Game? We're the initial kind of inceptors of Ignite and kind of gave it to Apache. We've got the Enterprise Edition, which is our guaranteed kind of build, a bunch of enterprise features that come on top of that, and our A-class kind of support that comes with that. The Visor, so back to the point of can we do monitoring and management for DevOps? It's a pretty good kind of implementation or UI where you can pretty much check everything that's in the grid, and run any operations and understand what's going on in there. We've got tiered memory, which I just mentioned before, so having the ability of an on-heap, off-heap, and a local swap store space that we can use. Data center replication, so we can support active-active replication across data centers, no problem. Active-passive. Network segmentation resolution, so if anything goes out of sync, we'll manage to resolve that, no problem. And should be one more. Security, it's probably an important piece. That's for the enterprise. Again, that's something that we offer as part of the GridGain enterprise version. So multi-tenancy and all sorts of different kind of protocols for custom security. Yes, so actually that was as part of the security. I think if we can't see my mouse pointer is gone for some reason. Yeah, we have very extensive auditing capabilities. It's not there, but I can point you to the website. You can see all as part of the Enterprise Edition, it's all about the auditing, the security, so all the stuff that matters, really. So, yeah, that's it. Hopefully I can take more questions now. We're good for time? What's,
we got maybe a couple of minutes for questions. That's the only thing that's holding us between that and bid.
Yeah. So, I mean, just a quick question. Does it make sense? Is this something new? Does it sound impressive? What do you guys think?
Yeah, that does sound impressive. That sounds so big. And
Yeah.
I'm surprised you don't make toast. How do you distinguish yourself between, say, Spark, as you said, Storm, and Ignite as well? They all come as Apache projects, and I have difficulty to realize which one does one better
Okay, I think the space that we're trying to be is, I think we want to be a bigger kind of encompassing technology. Like I said, I think our motto is about kind of solving high scalability and performance problems running in memory. So I think we have a number of different functions. It's not only a data grid, it's not only a compute grid. I think something like Storm or Spark, this is great when it comes to computations and distributed kind of computations, fantastic, but you see a lot of the times there's a mixture of stuff that's missing. So I think the space we want to play, I think we want to create the new kind of Hadoop or ecosystem of tools that will be in memory. So what is Hadoop now? I think for batch processing, we want to do that for in memory. We want to grow and have the ability to have all sorts of different projects be created on top of that. So it's all about kind of high speed and performance and scalability problems using in memory technology. That's it at the end of the day. I mean, there's a lot of projects right now that are similar space, like you said, Spark and Storm, and there's also a number of different other ones that are playing in the same space. So, yeah, you never know. I think it's place your bets which one is going to take off, and I think this one is the right one.
I think with that sales thing, we should thank both of our speakers tonight, and then move down to the pub if you want to ask any more questions.
Thanks.